Finding resultant vectors. Given two vectors acting upon the same object, find the resultant vector. We're going to start out with problems that are pretty simple, I hope that you'll find, and then we'll move into ones that are more complicated at some point. George is getting stir crazy from a self-imposed lockdown in his house due to IFAS DSW, irrational fear of sharks during Shark Week. He can't handle being in his house anymore, so he decides to don his cape and take to the skies, where no shark may harm him. Super George flies due north with an air speed of 300 miles per hour. There is a wind traveling at 40 miles per hour due east. What is the resultant course of Super George? What's its magnitude and direction? So let me first draw a coordinate plane. And let's just assume that this is north and this is east, although you don't have to do it that way. One of our vectors, he's flying north with an airspeed of 300 miles per hour. So I'm going to end up changing this picture a little bit, so just bear with me here. So one of these vectors is in the direction of north, and it's 300 miles per hour. There's a wind traveling east at 40 miles per hour. So that's another vector that's going in this direction. 40 miles per hour. What is the resulting course of Super George? Magnitude and direction. So what I would suggest when you do this, if it's possible, to make a reference triangle with these two vectors. So if I take this 300 miles per hour, this, I don't want to take the whole thing. I just want to take this part. Oh, geez. Okay, so if I take this, I can move this vector any place, and it's the same vector. I'm going to move it right here. You could draw this now. And we are after, if we go 40 miles per hour east and 300 miles per hour north, what is the resultant vector, this purple vector? Now to figure this out, really it's just right angle trig. So the magnitude of this vector, we'll call this vector v. That magnitude can be found with the Pythagorean theorem, which is the square root of the x component squared plus the y component squared. The formula for this without numbers is the x component and the y component squared. Now if we use a calculator, 40 squared is 1600. 300 squared would be 90,000. If we add those together, we get the square root of 91,600. And if we square root that, we're going to get about 302.65. We're going to just round to 2 decimal places. Now, what kind of units is this magnitude? We were in miles per hour, so it's miles per hour. Now we need to figure out the direction. The direction, which you can use this shortcut if you want. The direction that we're going to be in here, the reference angle, which is theta prime, but if it's in quadrant 1, theta and theta prime are the same. I really should have drawn this picture bigger. Whoops. Whoops. That's going to be tangent inverse of y over x. And in this case, it's tangent inverse of 300 over 40. Now, once again, why is it tangent inverse? Because if we did this long ways, which you're allowed to, we would do tangent of theta prime is the opposite leg over the adjacent leg. Then to get theta by itself, excuse me, I just belched. We would do tangent inverse to both sides. I'm not asking you to show this work. You can if you want, what you just saw there in red. I put this into my calculator. Tangent inverse of 300 over 40. That's going to get an angle. We're going to round the angles to the nearest degree, 82 degrees. If you wanted to write a sentence answer for this, which we're not going to at this point, but if you were asked to write a sentence answer, your sentence would be something like, Super George, the resulting course for Super George is 82 degrees in standard position with a speed of 302.65 miles per hour. Number 2. Growing bored while flying, Super George decides to fire up Netflix, where he serendipitously finds the comedically horrific movie Sharknado. George's IFOS DSW flares up instantly and he plummets back to the Earth's crust. Upon crashing in a deep forest, George travels 70 miles due west from his crash site. He then travels 150 miles due south until he reaches the Atlantic Ocean. Determine how far and in what direction George is from the crash site. So if we take a coordinate plane, see we're going west and south, I'll just put it like this. One of these vectors, he's going west with a magnitude of 70 miles. So that vector has a direction of west and a magnitude of 70 miles. And then he travels 150 miles due south. And if we draw this the way that I just drew it, we can draw a reference triangle, like so. And we are looking for this resultant vector, which I'll call W. We would want to know the angle in standard position. That's how we've been finding angles. There's other ways to do it, but I don't want to freak you out at this point. And then we can also find the magnitude. Before we find theta, we should probably try to find theta prime. Theta prime is going to be tangent inverse of y over x. Now, it is true that this 150 is down, so it's negative. But when we're doing this reference triangle for this, I think it's fine if we just treat this as an angle in standard position. Once we know this reference angle, we're going to add 180 to it. So if I put this into my calculator, that gives me a reference angle of about 65 degrees. But theta is going to be 180 plus 65, which is going to be 245 degrees. That's in standard position. What about the magnitude? The magnitude is going to be the square root. Whoops, we're using the Pythagorean theorem here once again. It's going to be the x direction squared. Once again, this x direction and the y direction are technically both negative because we're going left and down. But if you square it, it's going to become positive. And the y direction squared. This is going to be square root of 70 squared plus 150 squared. We can just simply skip the intermediate steps. This is about 165.53. What kind of unis we got? Miles. If you're asked to write a sentence answer, how far and in what direction is George from the crash site? George is 245 degrees from standard position from the crash site, 165.53 miles. So that's what this resultant vector is right here. Number 3, while sitting on the beach, George sees Willie swimming in the ocean and declares, "I will free Willie from the confines of the ocean." George swims at 2 meters per minute in the direction of east, but the wind is blowing the George's water. Let's get rid of that. But the wind is blowing George's water at 1 meters per minute in the direction of north. What's the resulting course of George? All right, so George is swimming 2 meters per minute in the direction of east, like so. So this is a vector, 2 meters per minute. And then we have the wind, which is blowing at 1 meter per minute north. And if I want to draw this using a reference, let me redraw that. That was not good. Coordinate plane, let's see, I'm going north, and I'm also going east. So George is swimming in the east direction, 2 meters per minute. And then I could draw my other vector here, which would be fine, but I'd rather have a reference triangle, so I'm going to draw it out here. 1 meter per minute north. The resultant vector that we're looking for would be this resultant vector here. This is theta, and the magnitude that we're trying to find, let's call this vector s. Order in which you do this doesn't matter. Let's say we try to find the magnitude of vector s. It's the square root of x squared plus y squared, and our x is 2, and our y is 1. It's going to be the square root of 5. If you wanted to put that into a calculator, get what that decimal would be, 2.24, that's fine as well. The units for this is meters per minute. That's the magnitude. That's the speed, if you will. If we wanted to find the angle, the angle for this is going to be tangent inverse of y over x If the angle's in quadrant 1, then theta and theta prime are the same thing. It's the angle in standard position, it's also the reference angle. That is going to be about 26 degrees. And like I said, angles, we're going to go to the nearest degree. So magnitude, direction, 26 degrees in the standard position. Last one. While swimming, George notices a potato floating in the ocean. George smiles and says to himself, "Potato." But his smile soon dissipates when the echo of potato reminds him of tornado. With his Rhophus DSW, a rational fear of sharks during Shark Week, banging on all cylinders, Super Georgie emerges into the sky and flies to the moon. He flies straight towards the moon at 300 miles per hour, but the wind is blowing at 50 miles per hour in the opposite direction of his flight path. What is George's magnitude and direction? Well, the direction is going to be simple. So George is flying towards the moon with a vector of 300 miles per hour. And then we have the wind in the opposite direction at 50 miles per hour. As far as components goes, these only have y components. There's no triangle that we can draw from this. Let's call the resultant here vector r for resultant. Its magnitude, in this case, since there's no triangle, it's just going to be 300 in the positive direction and 50 in the opposite direction. That's 250 miles per hour. And this direction would be towards the moon. If we had gotten a negative number for this, we would say away from the moon. That's all you got to do for this last one because there's no triangle that can be made for that. Please do the homework and try to make it short for you.